Have you ever wondered whether black holes are real? No, seriously. We know that things can fall inside them, but we also know that they are one of the clearest examples of the holographic principle. So, are black holes real or are they some kind of hologram? Oh, I'm getting something on my phone. Just a second. Hello? Oh, hi. Speaking of holograms, what is it? I'm trying to make a video talking about black holes here.
Hey Dad, can me and my friend play in the hollow room?
Yes, you can use it. Just don't bring your Legos in there again. Bye. The last thing you want is to be running from a hollow T-Rex in bare feet and step on a Lego. Where was I? Oh yes, black holes. Think about it this way. My daughter is a real person whose holographic image can be collected by two CCDs in a holographic camera, sent across to my phone, and reprojected from another two-dimensional surface to make it appear as if she were here in the room with me. On the other hand, a holographic T-Rex is simply a recreation of the 3D image of a T-Rex. There is, I hope, no real T-Rex in a game studio somewhere being trained to make holographic games. That means that, unlike my daughter, all the information about the T-Rex is held within a two-dimensional surface of the projector. Black holes are similar, and we've known that for about 50 years, long before the first black holes were seen in telescopes. Unlike ordinary objects, the amount of information in a black hole doesn't grow with the volume, but with the surface area of its event horizon. And that makes you wonder, is there anything in there? Well, Einstein's theory of general relativity, of course, tells us there is stuff inside a black hole. In fact, it all falls in and eventually reaches the center, where it is packed into an infinitely dense singularity. But whether or not there is stuff inside the black hole, the information that falls in, what makes one thing distinct from another or how two things are interrelated is spread across the surface. The black hole is like the holographic CCDs that record anything that falls in. And that leads to the mind-boggling conjecture that all the things that fell in were all just projections in the first place. But projections from where and by whom? At best, we can guess that everything is projected from somewhere, perhaps the distant future or some boundary of the universe to which we are unaware, maybe infinitely far away. Whatever is there on that boundary is just quantum information, like the zeros and ones that make up the information that can become a hollow T-Rex. It isn't as if there are two-dimensional images of us infinitely far away and infinitely tiny on the boundary of the universe. Instead, waves that make up our atoms and all the forces that bind everything together get started as patterns of quantum information at that boundary. They are then projected into the universe in some way, but all the information those waves contain lives on that boundary, much like the holograms and the light waves that emerge from hollow projectors. This means that black holes are simply objects that pack information so tightly that they expose the 2D reality of our 3D illusion. It's the same with, say, a pixel on a screen. Everything is, eventually you make things so small that they're just a single pixel. There's a limit to the density of information, and when you're projecting something, that limit is a feature of the thing doing the projecting, not the thing being projected. If this is true, then information does not, as we might naively expect, grow with the volume of our universe. So even though the universe itself is expanding, it isn't gaining new information in proportion to its increased volume, but rather to its increased surface area, the surface area of the observable universe itself. It turns out if you take that amount of information and use it to try to compute the amount of dark energy in the universe, it is pretty close to the value we measure. If you assume that information grows with volume, however, you get a number 120 orders of magnitude too large. To get really good agreement, you don't use the size of the observable universe actually, but you use the size of the universe's future horizon. That's the maximum size of the universe that we will ever be able to see, which is actually a finite quantity because the universe is expanding and all the matter will eventually get too far away from us for us to be able to see. It means that also at the smallest scale possible, we do not in fact see a lot of energy from things popping in and out of existence as quantum fluctuations. We just have a maximal resolution of our holoprojector, which is a size called the Planck length. At the Planck length, the universe would reveal itself unambiguously to be a projection. We would see noise related to the projection itself. In fact, at Fermilab, a lab near Chicago, an instrument called the holometer is trying to find exactly that noise in the fabric of reality itself, looking for the pixels of the projector, the fabric of space-time. This noise in the deep would help us have confidence that we live in a holographic universe. So far, it hasn't found it. But how likely is all of this to be true? On the one hand, we don't have evidence in favor of the holographic universe. All we have is theoretical calculations and about black holes, and that emerges from Einstein's relativity, which is well established, but the holographic principle applies all over the place in physics. It exists in relativity, but there's no evidence that reality is a projection. It is a strange coincidence that the holographic principle does pop up a lot in quantum physics, as well as relativity, and there's a connection between the two. That means it's a worthwhile pursuit, and certainly something that we should do experiments on. Despite that, the best holographic theories we now have apply to universes that don't necessarily look like ours, and nobody really knows how the holographic principle applies to this universe. I have some ideas about how that might get solved. You can see my latest article on Substack, but now I need to get going. And so if this turns out that we are holograms, I for one don't mind it. It makes getting around a lot easier. Bye.